Now in this video, I want to talk about an absolute value function, alright? Good. Maybe let me just give you a little explanation to it. Now when we talk about an absolute value function, it's just a function that evaluates any given input and give us a result to be a non-negative value. So for any real number you plug in, positive and negative, the result from that function, the output, is going to be non-negative. Now it can either be 0 or bigger than 0. And this is how it goes. Now, an absolute value function, value. Alright, good. So, an absolute value function denoted by this, okay, such that notation, okay, takes every real number to this interval from 0 to infinity with 0 included. Is defined by the absolute value of x to be x if x is bigger than 0, then 0 if x is equal to 0, and then negative x if x is less than 0. That is true for all real numbers x. Great. So what we've got there is just a definition, okay, or a structure of how the absolute value function behaves. Whatever you give to it, okay, absolute value of something, whatever you give to it here, right, it is going to produce that thing. If that thing is bigger than 0, it's going to produce 0 if what you plugged in is equal to 0, and it's going to produce the negative of what you plugged in if what you plugged in is less than 0. Now, that will help us to evaluate the following examples. What is the absolute value of 5? It is going to be 5. Reason being that the absolute value of x is going to be x if x is bigger than 0. So the absolute value of 5 is equal to 5 because 5 is bigger than 0. Good. If I give another one to look at, what is the absolute value of 0? Well, from this definition, the absolute value of 0, okay, of x is going to be 0 if x is 0. So if x is 0, that means this place is 0. Therefore, the absolute value of 0 is equal to 0. Good. Again, let me give you a final example, which, of course, is going to work for the third one. What is the absolute value of negative 2? Again, from this definition, we saw that the absolute value of x is going to be negative of that x if that x is less than 0. What you plugged in here is negative 2, which is less than 0. From the definition, we are going to take negative of what you plugged in, negative of this x, alright? So in this case, this x is negative 2. We're going to take negative of this negative 2. Good. And this gives us positive 2. That means that the absolute value of negative 2 is positive 2, the absolute value of 0 is 0, and the absolute value of 5 is 5. Well, for all real numbers, that is how it will work out. And if we want to plot that on a graph, we're going to have the graph to look this way. This is the horizontal axis, right? Maybe you can denote it with the x, so we are talking about x as input, and this is the vertical axis. Good. For every real number you plug in here, when you plug in 0, the output is going to be 0. That's just the origin. If you plug in 1, let me just label the axis a little bit. This is 3, 1, 2, 3, and then the negative x-axis. Good. So if you plug in 0, it gives us 0. If you plug in 1, the output is going to be 1 because 1 is bigger than 0, right? When you plug in a negative input, negative 1, the output will be negative of negative 1, just as it happened to 2, which is going to give us positive 1. This will be positive 2, and this will be positive 3. And then that's how it will go, right? So we can have a straight line, right? Good. So this function is called an absolute value function. Great. Well, let's use this absolute value function to evaluate the following problems, all right? Good. We have the first one to be x plus 3, absolute value of x plus 3 equals to 5. All right, good. So we want to find the values of x that will satisfy this equation. Absolute value of x plus 3 equals to 5. So we want to find all real numbers, if they are more than 1, all the real numbers that when we plug in here in place of x and evaluate the absolute value, it's going to give us 5 as a result. Now from this definition of absolute values, we say that the absolute value of x will be x if x is bigger than 0. Now that will give us an information that the absolute value of x plus 3 will be x plus 3 if x plus 3 is bigger than 0, right? Okay, good. It will be 0 if x plus 3 is equal to 0, and it will be negative of, absolute value of x will be negative of that x. So, absolute value of x plus 3 will be negative of that x plus 3 if that x plus 3 is less than 0. Right, good. Okay, let's see what we've got. We've got that the absolute value of something is going to be that thing if that thing is either greater than 0 or equal to 0. Now, the absolute value of this gives us 5, right? So that means we are going to write from this first equation, we're going to put that the absolute value of x plus 3 is going to be the same thing as x plus 3, which is equal to 5. Okay, the absolute value there equals to 5. From there, we can get x by subtracting 3 from both sides. That means x will be equal to 2. Good. So if you plug in 2 into this equation, 2 plus 3 is 5. Absolute value of 5 is 5, and that's it. Alright, good. That is for the first part of the answer. And then we're going to look at the second part. We have absolute value of x plus 3 will be negative of that if that right there is less than 0. Right? So let's look at it. We have negative x plus 3 will be equal to 5. Since negative x plus 3 is the same thing as the absolute value of x plus 3, and we equated that to 5, that means this is equal to 5, right? Okay, we can multiply negative 1 by both, can multiply both sides by negative 1 and subtract 3 from both sides. That will mean that x plus 3 is negative 5, which tells us that x is negative 8. Good. So with this new value of x, that function will be defined, or the left hand side will be equal to the right hand side. This tells us that x equals to negative 3 and x equal to 2 will satisfy that given equation. Okay, great. Alright, thanks for watching, and please subscribe to my channel.